Hey everyone, this is Michael from the Data Incubator. Wait, am I on? Yes, okay. Hey everyone, this is Michael from the Data Incubator. Really excited to have you with us. We'll be starting momentarily. We're just waiting for a few more folks to sign on, so if you're already here, hang on tight. Just a few words about who we are and what we do. So I'm Michael, I'm the founder of the Data Incubator, and we offer a free fellowship for PhDs and master's students in data science. So today we'll give you a bit of a sneak peek as to what that'll be like. But if you want the full thing, you can go online to our website, www.thedataincubator.com, and learn more about what we do. We also offer corporate training options for companies that are looking to train their existing staff. So you can sign up for that at our website, again, thedataincubator.com. And if you're interested in hiring data scientists, we also work with companies who want to hire from the fellowship. So again, you can go to thedataincubator.com to learn more and sign up there. So if you want to follow along, I would really suggest you sign up, so you check out our GitHub account. You'll see the repo for this data science in 30 minutes, as well as the repos for the previous data science in 30 minutes that we've done. It's a great way to be able to follow along and continue to be able to play around with this material as we're presenting it. So you'll need to be logged in to Google if you want to ask any questions. So you can do that at the YouTube page, which I think my colleague has also sent out to you in the email that you would have gotten after you signed up for this. So please feel free to pose any questions and we'll be happy to answer them at the end. I know some people had some issues relating to setting up Conda. So depending on what version of Conda you're using, you either need to use the env or not use the env. So please, feel free to do that. I know this data science in 30 minutes is a little trickier because we had a little bit more setup to do. So I hope you guys were able to get that set up sort of configured. So the nice thing is that for the fellows and the scholars that join us in the fellowship, we have the environment provisioned for everyone so that you don't have to deal with any of these kind of installation setup issues. And you're able to just dive right in and start learning. So now I'm going to share my screen with you. So you should see that momentarily. And we're going to begin by looking with the IPython notebooks. So there's actually two IPython notebooks today. We'll be talking about Spark streaming and then how to process a little bit of data in Spark. We're going to pull down a bunch of data from Wikipedia. It's actually a feed of the live edits that are happening. And we're going to then parse that and do some interesting summary statistics on that. So we're all going to do this all in Spark. As I'm sure many of you know, Spark is sort of a leading engine for distributed computation. We want to give you a bit of a flavor of Spark, both Spark as well as PySpark. And we'll sort of show you a little bit of how both of those work. So without further ado, I'm going to open up here. There's a streaming collection notebook. So if you click on it, you'll open it up and you'll get this IPython notebook. I suggest you load these dependencies right away because it takes a little bit of time to get that all squared out. And while you're doing that, I've already pre-run them. But while you're doing that, I'll say a few words about what is Spark and a little bit about the sort of computational model. So the idea of Spark is it's a way to do distributed computing easily. So the first half of that, what is distributed computing? Well, obviously, in the era of big data, we're going to have lots and lots of data. And sometimes that data won't be able to fit in the RAM of your computer or even the hard drive of your computer. And you'll need to be able to distribute that data onto multiple computers. So Spark is a way of handling that. And doing it in a very seamless way that abstracts a lot of the kind of pesky details of distributed computing from you, which is kind of nice. In many ways, people think of it as a successor to MapReduce. And I'm sure you've probably seen, whereas MapReduce, a simple word count will take upwards of 100 lines of Java code. In Spark, a simple word count will take 10 lines of code. It's a pretty compact way of writing code without having to deal with a lot of the overhead issues of distributed computing. So again, we'll be using, for those of you who just joined, we'll be using Spark. It's a distributed computing engine. We're going to do this using a standalone method, but obviously the kind of intended use case is in a distributed way. So I'm only running on a one server that I have, but you can of course run this on multiple servers and get n times as much power by distributing that workload over n computers. So we'll do something that we really like to do in the course, which is to talk about packages or concepts in terms of nouns and verbs, because I think that's a really useful way to think about all these different packages. So the first question is, like, what are the nouns of Spark? And the basic noun of Spark, the basic object you have, is something called a resilient distributed data set. So what is that? You can think of it as, from the user's perspective, from the person who's writing the code, that's just like a list. It's a very long list. You can run commands over that, but it's more or less how you would handle a list in Scala or Python. You can map over it, you can flat map over it, and you can filter over it. And then you can sort of apply these functions to arbitrary elements of the list. Now, there are also newer elements. So there's also DataFrames, and even even newer than that, data sets. We won't talk about that so much today. It's definitely a topic that we covered in the fellowship, but for the interest of time, we'll stick to just RDDs. So what's so special about an RDD? Well, a lot of it is that it abstracts out a lot of the elements of computation. So I said that you can treat it as a list, but what it really represents is the data that's distributed across all these different computers. So you interact with it as if it's a list, but what's actually happening under the hood is when you say, apply this transformation to every element of the list, Spark is going out to every single worker node, which could be across multiple servers, multiple computers, and it's performing that operation. And if you say, I need to do a group by or a join, it will shuffle the data between the computers in a way that's efficient and smart. So that's kind of what an RDD is. The second question you might ask is, what is what are the verbs? So the verbs are transforms. So the idea here is that you can apply a map, you can apply operations like map, flat map, and filter, which are the basic operations of lists and kind of functional programming. But you can also apply more complex operations like group by or join, all the operations that you're familiar with in SQL. And we'll highlight some of that a little bit later in this presentation. So let's get started with the code. So the code is sort of made to work with two different data sources. Today, I will just be talking about Wikipedia, but you can also do the same thing with Twitter, and the examples are very similar. So here I am going to load some constants. this is really just telling Spark this is where you should look for a live stream of Wikipedia edits. And now we're gonna do this in 2 steps. The first step is we're going to load in a bunch of data from the internet, and we're going to do that in a streaming way. So as people are making these live edits on the internet to Wikipedia, we're going to get a live stream of this, and we're going to pull this down using Spark Streaming. So Spark Streaming is a lot like Spark, but instead of sort of having one fixed collection of large data, we're going to be ingesting a constant stream of data. And the way streams work is through this thing called this dstream or discretized stream. So every, in this case, we set our interval to 10 seconds. So in every interval of time, we will get back an RDD, a resilient distributed data set. And this data set will have all the information that we've collected in the last interval or the last 10 seconds. So you can see here that first we have to create the streaming context. It's a little bit of overhead. This is the JVM after all. We then have to create the stream, which is pretty straightforward. And then we start computing through it. So we start computing through it. So I'm going to do the Wikipedia examples. If you set up your Twitter credentials, you can also do this in Twitter. But so right now we're going to set up a socket connection to the Wikipedia server, which is this anonymous AWS server, and it happens to be talking on port 9002. And then we're going to just run this code. So this is doing a lazy computation. It's going to pull in all this data, and it's going to then save it to this folder called data/. Now, this, I want to say 2 things about this really quickly. One is, notice this is, we're running for each RDD. So this is an example of how you can treat the stream, even though it's a distributed stream, it could be happening across multiple computers. But all those details are hidden from you. And all you're saying is, I want to do the same thing on each node. And you say, for each RDD, do this computation. And basically, it's as long as the RDD isn't empty, we're going to save it to a disk. Save it to disk in the directory data/. And of course, in the real world, this would probably be saving things to Hadoop. So this would be like an HDFS location, and you'd be saving on a distributed disk. But for now, we'll just save it to our local disk because we're running this in standalone mode. And you'll notice that I hit run, but nothing's happening. This thing returned right away. It's because all I've done is define what the computation will be. I've told it this is what I want you to do on this stream. But nothing is actually happening. It's what you call a lazy computation, what you might think of as a lazy computation. To start this, I'd actually have to say sc.start. And now this is starting to run in the background. So I can come over here, and I'm just going to sort of highlight this. So a while ago, I started downloading this data just to check this earlier in the afternoon. And if you, here, I can even make this bigger because I'm sure it's hard to see. But if you start looking, if you look at what's happening, you can see this number incrementing up with time. So I'm using watch to see how much data is there. And you can see that as I am downloading this data, as I've run this, the number of files is increasing. I'm just adding to the amount of data that's there. So you can tell that I'm now downloading the data and saving it quite nicely. All right. So now that we're downloading the data, let me switch over. So we'll go back to the home of the IPython notebook, and you can look at the other IPython notebook, streaming analysis. So streaming collection was all about pulling in the data. Streaming analysis is all going to be about how we analyze the data. So in streaming collection, you'll notice that that was all in Scala code. So we were writing it in the native language that Spark was intended for. Here we're going to use some of the newer APIs, like DataFrames, and we're going to well, DataFrames in SQL primarily, and we're going to be doing this in PySpark. So PySpark is basically a thin Python wrapper around the Spark API. A lot of the commands are similar, but it gives you a little bit more freedom because Python is a slightly freer language. And so it might be a little bit more useful for analysis. So now I'm going to run this. Again, all I'm doing here is doing some imports. In particular, I want to make sure I also get matplotlib, which is one of the dependencies that was installed in your conda file. Now, just to make sure everything is working. Oh, no, it's not. Okay, let me try this again. Kernel restart. I should probably not run those imports twice. Okay, so now it's, so this is, okay, so Spark is very finicky. It doesn't want you to import a kernel more than once, so, or create a Spark context more than once. So when I run this twice, it's going to give me an error. So I will be very careful to not run that cell again. This is creating the Spark context, which is sort of your gateway into Spark. It's an object that holds all the commands that you sort of really want to use. So now I'm going to run the next line of code, which is creating the SQL context. This is going to allow me to really kind of start running SQL queries against this, which is a really nice feature, especially if you're very familiar with SQL, but maybe don't know as much about Spark. So now I'm going to read data off disk. So you'll remember that we've been slowly gathering data in this data slash file. And we've been sort of slowly accumulating it. It was at 17,000 earlier, now we're at 18,000, and you just saw the number increment. And if you do this on your computer, you'll see it increment as well. But oh, there was a request to make this bigger, so I just made the screen a little bigger. Sorry about that. But so to make this analysis a little easier, we're going to read from Wiki Cache, which is a cache that we previously downloaded of some live edits on Wikipedia. So this is a bit like the cooking show where they sort of show you how to marinate the chicken, they put it in the oven, and then they pull out the chicken that's already cooked. Here's the chicken that's already cooked. We're going to be, so in your repo, I think it says data here instead of Wiki Cache, but we're going to be reading from the Wiki Cache. And you can feel free to read from that as well if you want to make sure that you're getting the same results that we are. So here we're using Spark text file. We're going to read all this data into this variable. And let's just check to make sure that we have the right number of partitions. Number of partitions here is going to roughly be the number of little files that's being that the data is being stored on disk as. And now I just want to make sure. I think this is going to, oh, really, 4? Okay, so now we can run this computation, and you can see as it's running here, and it will take a little while to finish. We're just counting the number of elements in this partition, and we'll even show you a sample of what those elements look like next. But as it's doing that computation, that data is getting persisted. So you can go to, if this is the first Spark kernel you start up, you'll be going to port 4040. That's the default port to show this in. But if you're like me and you've created several of these Spark kernels, you'll have to increment your port number accordingly. And I'm currently at port 4044, which is fine. And this sort of shows, you can see the jobs that are running at this or have run. You can look at the various stages of these jobs, and you can look at the storage. So this is kind of a useful thing to be able to watch. Next step, of course, is just, let me just show you what one of these samples looks like. So here I'm just running the take operation, which takes this JSON RDD, and if you just want to see it, it's, you know, if you ask PySpark what this is, it will give you some sort of kind of smart aleck answer where it says, hey, yeah, this is just some object I pulled off disk. It's not going to tell you what's actually in the object. It just sort of says this is an RDD. We got it from a text file. Don't ask too many questions. If you actually want to look at the contents of it, what you have to do is run something like an operation like take, which pulls it into your process's memory. So this is actually going to return a Python list, a good old-fashioned Python list with all the elements inside. That's actually a little hard to read. So let's just take a look at the first element. You can see what type it is, and we can print it out. So apparently it's giving to me as a string. And this is what the string is. And you can clearly tell that this is supposed to be some JSON. And if you kind of read through it more carefully, you'll notice that this is actually a JSON representation of some edits that are happening live, at least live when we were collecting the data a little while ago. And it tells you where they were made from, the longitude and latitude. It gives you some location information. So apparently it was made by somebody in New York. Gives you their IP address. Tells you the name of the article that was edited. That's this page. And it gives you the URL and so on of the pages that were edited. So that's kind of useful. So let me now do this. So I am going to take the JSON library, which is a library that exists that comes standard in Python, and I'm going to load or parse. Well, the function is called loads, or load from string, and it's actually just parsing this string of JSON into an actual useful representation. And the reason you know that it's doing that is because the JSON sample, when you ask what type it is, it's going to give you back a dictionary, which is what this thing would be represented as in Python. And in fact, we can even then print this back out, but in a pretty way. So JSON dumps lets you do that. You can have the keys sorted. You can indent things. And now it's much easier to read this blobblygook of data that was up there. And you can sort of see a little better all the things that were happening. Two things you might want to pay attention to are the comments. So in this case, this user didn't make any comments, right? But also the timestamp. So you can pull out the timestamp that the user edited, the time at which this edit was made. So you can see it was made the 23rd of August of this year. So, okay, this is good. And the nice thing about using the Python interface is that it's really easy to kind of pull some data out and manipulate it in Python so you can see what's going on. But now that you've done that, you probably want to actually do this not just for one piece of data, but across all the data. And now we're going to do that here. So it's the same thing. We're going to read from this Wikipedia cache. And we're going to start applying some of the operations. So the first thing is to look at this delta. So you'll notice that as we're reading this, we're saying .read.json. So we're telling Spark that we're expecting the data that's coming from here to be in JSON format. And so it will know to parse this naturally, which is quite nice. You'll also notice that we're going to ask it for the delta field, this delta. I believe it's the number of changes that are happening in that edit on Wikipedia. So we're only going to look at substantial edits, edits that were more than 50 lines of code. And then we're going to select out two columns, or two of the JSON values, which are the channel and the page. So you'll see that there's this channel, and you'll see that there's also a page. So what page was edited. And then we're going to show 5, which will print them to the screen. So I'll run that right now. And you'll see Spark sort of thinking and sort of doing this in a distributed way. Now, the next line is going to be what you might be doing to augment the data frame. So these data frames are a lot like the data frames in pandas or the data frames in R. And one of the things you want to be able to do with a data frame is to be able to say, hey, I want to add an extra column to it. In particular, I want to add an extra column, which is this, which we're going to define this way. This channel 22. So that's a little mysterious. But what's happening is we're basically saying select off the channel column, which again, for every element is just going to pick out this value, or I should maybe more appropriately say this value. In this case, that's hashtag English.Wikipedia. And we're going to pull those out, and we're going to add it to a column called location. But before we do that, we're going to do a little bit of selection. So this is a slightly mysterious selector, but what it's doing is it's pulling out these two characters. So we're just trying to pull out the language of the channel. Now, we could have done that by just asking which Wikipedia this is, but this is just there to show you some of the power that you can have. You can perform these operations for the entire column, every element of the data frame. So we will pull this out. This creates an entire data frame. And then we just say register temp table. So this is basically telling it that in the SQL world, in which I'm going to run a SQL query shortly, this data should be equal, is what I'm going to refer to this new table that I've created as. So it creates this table within the sort of SQL interface that you get to use. And then I get to just run queries like this, which are good old-fashioned SQL queries that you're probably familiar with. So you'll see here the output. Here we're just we've probably skipped some of the minor edits in choosing this. So you'll see that there were 3 edits of Wikipedia English about dragon boats and printing and this thing that I can't pronounce. And then there was a edit on Wikipedia, the Danish Wikipedia for Ryan Lochte. Now, that's what this line is outputting. This next line is really showing us aggregation. So we're now going to count how many, we're going to use SQL to help us count how many edits there were in this little sample based on what country they're from. And this is why we wanted to compute this location field. It tells us what the country code is for that Wikipedia. And we're showing it here. So you can tell that the most number of edits at this point in time, or for this little sample, were English Wikipedia, and then German, and then French, Spanish, Italian, and it goes on. So that's pretty cool. So the next thing I want to show you is that you can, the nice thing about this is that, or about using PySpark, is that we can start interoperating with the Spark API. So one thing you might want to do is pull out this timestamp and convert these elements to actual datetime objects. So these are the datetime objects that you know and love in Python. And that will make it much easier for us to parse these otherwise pretty complex time signatures. So let's see, it's the timestamp column that we're pulling out. That's a pretty complex thing to be able to parse. And I want to be able to do it really easily. So I'm going to run this command. And basically, this is just going to parse each row as JSON. This is going to give me the element as well as the timestamp associated with it. And it's going to then parse that timestamp based on this format into an actual datetime object. And then we're going to cache it. And so caching is one of those little tricks that can help really improve the performance of Spark. And you'll see this will hopefully happen a lot faster. But what we're going to do by ensuring that all the data is put into memory as opposed to being put on disk. So maybe I'll say one quick thing about the way Spark works. Normally, when you do distributed computing like in MapReduce, everything is all getting to a hard disk is really slow. The cache in Spark allow you to selectively keep memory in, or keep data in memory, so that while the data might not be able to fit in the RAM of your computer, maybe can fit in the collective RAM of your cluster. So if you have 100 computers working for you, maybe the data won't be able to fit in your RAM, but it can fit in the RAM of that network or that cluster. And Spark will intelligently try to keep data in RAM for you to help maximize, or to help, maximize throughput or minimize the amount of lag from serializing to disk. But cache kind of gives it, helps it do that a little bit more. Here that we can filter for all this data. And in this case, I'm just saying I'm able to use the Python datetime API to call out the second. So I'm saying I just only want the edits that were made in. That's what this filter operation is doing. And it turns out there were 39 of those. And now I'm going to basically run a calculation to calculate how many edits happened during this at each. So this is going through and pulling out these values. We are action of those are happening who were anonymous edits. So what I'm doing is I'm going to pull out the second, and then I'm going to look at anonymous edit. I'm going to reduce by keys. I'm just adding all of these things up. And then I'm just going to look and take the total number of anonymous visits and divide that by the total number of visits. So you'll see what's happening is that I'm literally just going to keep track of the total number of anonymous visits that are happening at each point in time and the total number of visits. And that's already finished. So we can, of course, take a look at what this data might look like. But even better, we can plot what the data looks like. So here we have the seconds, seconds from 0 to 60. And we can sort of see what that trend looks like. And you can see that there's a good amount of variation, but usually about 20% of the edits on Wikipedia are happening or are made anonymously. And sometimes a little higher, sometimes a little lower. Of course, this is just a kind of toy example they can play with. I'm sure there's many more interesting things you could actually investigate. And you can also, instead of pointing it to Wiki Cache, you can go try pointing it to data, which will take a little longer because it's much more data there. But then you can start seeing some actual patterns and see if there's any interesting trends that you might be able to pick up. So that's all I wanted to say about this little demo of pulling in live data from Wikipedia and being able to analyze it using the Spark API. If you're interested in learning more, I suggest you let me switch off screen share. Yes. Okay, there we go. If you are interested in learning more, I suggest you look at our website. We have a few offerings that we're doing. So we will be doing a data analyst course later in the month. We'll also start doing our fellowship applications. So the application process is now open. You're more than welcome to come and sign up or apply to be a fellow at the Data Incubator. It's totally free for fellows who join us. And it's an 8-week fellowship that covers this, as well as a whole bunch of other topics in data science, from machine learning to ETL to distributed computing. So if you have any questions, I would suggest you write them out on our Q&A. And while they're accumulating, let me just make one final plug. If you're interested in either becoming a fellow, data scientists, or corporate training for data science, we really suggest you sign up at thedataincubatoR.com. You can put in your information. You can put your information down, and we'll reach out to you with more to follow up. And now I'm going to move over and start questions. For those of you who have questions and missed the beginning part, you can pose questions by going to the YouTube channel. You have to be signed in, and you can just answer, pose your questions there, and we will answer them, well, right now. So my colleague is going to top. Okay. Okay, so there's a question online about people experience and whether we welcome people with industry experience, and we're absolutely happy to do so. In fact, many of our fellows, although by no means all of them, have a number of years of industry experience, have worked before as either kind of software engineers or data analysts, or in various capacities. And we're quite, we are agnostic as to whether or not you have had prior work experience. Oh, whoopsies. Okay. Oh, so there's a question about 2 on Python 3 for standalone programs, and how to do that. What you really mean is PySpark, and it is a little tricky. So I actually only use Python 2 because I just never bothered to make the conversion to Python 3. And I've had pretty good luck. And actually, generally, when I write Spark, I don't even use PySpark. I just use Spark. So certainly, building standalone apps on Spark with, standalone Spark apps in Scala using SBT, the Scala build tool, that's actually pretty straightforward. And I think if you look at our GitHub, you can even find a few examples of standalone projects. So you can just copy that template and use it. And if you want to look that up, it's at github.com/Data Incubator, all one word. And you can find some examples of working Spark projects that are standalone, not these kind of IPython or Jupyter notebook strips that will allow you to kind of just compile down to a binary. It is a little finicky. I think you need to use assembly, SBT assembly. It's recommended if you want to package up the app and distribute it. But there's a healthy amount of that. And of course, it's one of the topics we cover in our fellowship. So if you're interested in that, or if you're interested in corporate training, I really recommend you go to the website and sign up .com. Okay, cool. So seems like well, thanks for all the thanks. I guess some people had some questions about Spark, and there was a question about streaming and whether it should be live or not. The point is that because I was reading in the data from Wiki Cache, this was data that we prepared a while ago to make sure that this would work. If I were to point, this may or may not work, then that would give me the live data, and this will probably take a while. But let's take a look. See, this is actually happening today. So this is 2016-09-20, which is today's date. And maybe this will be a little easier. Oh, sorry, I forgot. Yeah, I'm not showing my screen. Anyways, all I did was I edited from Wiki Cache to data and reran this. And you can tell that now we're getting data that's live because data is data that I've been collecting today. Wiki Cache was something we collected a while ago just to be able to demonstrate this. So yeah, no, that's a good question about the timestamps. And Do you use any particular cloud computing services for your Spark instances? So yeah, so we, for the fellowship, we run everything on DigitalOcean. They're kind enough to give us some instances to run on. And that's actually, we've had quite a lot of luck because using that, because it's basically just giving you in the cloud. So we just sort of provision our own Spark instances up there. In fact, I'm sure if you've sort of tried to get, it sounds like from the comments, a lot of people have been trying to get Spark to work and perhaps having some difficulty. It is kind of, Spark, Python, all these tools are not always easy to install. So one of the things we do for the fellowship and for the corporate training is to basically provision machines for folks so that they can get out of this DevOps stuff and start going to data science right away. I know it can be kind of tough to get all this software installed just to like run your first Spark job. And that's one of the reasons we just sort of set everything up for you when you come into either the fellowship or for a corporate training. Okay, so there's a question about the data analyst program and what qualifications we're looking for. So data analyst program is really, it's a foundations course, right? The idea is foundations of data science, and it's geared, we almost think of it as a prerequisite for the fellowship. Obviously, the people coming into the fellowship already have it, but we want to build a course that could be taken by anyone who's maybe used to using Excel or kind of playing around with macros and formulas, but they want to take their data analytics to the next level. And this is to kind of get you started. Obviously, we won't be just doing distributed computing right away, but there'll be a little bit of introduction to machine learning, and it'll be a little bit about kind of how to wrangle data and data. And so we'll be, so that's what the course will be about. And it's also very much geared towards working professionals. So the class is going to be in the evenings, and it'll be online so that you can take it easily. There's a question about getting better at Python basics and fundamentals. So one of the things that we do for the data analytics course and this kind of foundations and data science course is we have everyone go through a small set of preparatory programs to get kind of familiar with a lot of the really basic parts of Python. But then a lot of what we're doing within the course is kind of getting you caught up some more on the kind of better programming styles, some of the more advanced language features. But for the basic if statements, for loops, that kind of stuff, I think we often recommend the Code Academy website as a good place to start, and get your feet dirty a little bit, and then our classes then our data analyst class is then a good place to start for starting to learn more Python and more about coding. Cool. So I think that's about it. Thanks so much for all the questions and everyone's enthusiasm in participating in this course. We will be sending out a little email with the YouTube video version of this in case you missed some parts or you want to go back. And of course, we'll probably make a few edits to the IPython, so to the Git repo based on some feedback that people have provided. So, and of course, feel free to make a pull request. We'd love to see people's. We love to get your feedback and your edits as well. So, well, thank you very much. This has been Michael from the Data Incubator, and thank you so much for taking the time to listen to this latest installment of Data Science in 30 Minutes. Cheers.